Yo, welcome back. So we did some quadratic inequalities, right? I'm just going to go over a couple of quadratic inequalities that may seem maybe not so obvious at first. Okay, so the first thing, let's say just question one for this video. Let's try this one. 4 minus x squared is greater than 0. So how do I solve this inequality? Now the first question I might make is the x, it's got a negative sign in front of it. Now, although that's doable, like we can work with that, I'd rather not work with a negative sign. So I'm going to multiply everything by a negative 1. Okay, I'm going to times negative 1, and I'm going to times negative 1. Okay, so on the left-hand side, we should get minus 4 plus x squared, and switch the sign, and 0 times anything is 0, so I'm just going to leave it like that. Okay, so hopefully you remember that if you multiply an inequality by negatives on either side, we have to switch it around, right? Let's rearrange this guy, and let's try to solve this equation instead. By the way, I might also add another way to think about it. If you don't want to think about it as like, okay, let's multiply everything by negative 1, it's the same idea as just switching sides. Like if I add, say, x squared to the right-hand side, and then I subtract 4 onto the right-hand side as well, like you essentially get the same thing, right? But yeah, basically the idea is we just want to make the x squared a positive so that we can work with it a little nicely. Okay, so hopefully that was all good. Now, a question is, how do you factorize x squared minus 4? Now, hopefully you remember that this is one of our special factorizing techniques called difference of two squareds. Probably, maybe, I think the first one on your reference sheet. And it's x minus 2, x plus 2 is how we factorize it. So if I was to draw this graph, so we have 2 minus 2, and it's just a parabola. Okay, so this parabola is less than 0. So 0 is this x-axis. So less than that means this part of the graph is the solution. And to describe it, it's these x-coordinates, right? So between minus 2 and 2. So let's say minus 2, x, and 2 is the solution. Okay, so not actually that difficult, but at the very beginning, it may catch a few people off guard. Sometimes, like, a very common mistake is people will factorize this the way it is from the get-go, like 4 minus x squared, without switching it to x squared minus 4. And they might just factorize straight away like this, which again, nothing wrong with it, which is the good thing about math. You can do this, completely legal, but there's a secret negative there, okay, which means when you graph it, you might have to draw a concave down graph, okay, because it's actually a negative on the left-hand side, right? And then you would be thinking about when the graph is above 0 as opposed to less than 0. Everything's flipped around. Okay, so hopefully that made sense. Let's try to do another trickier question. So yeah, another one. So again, not necessarily so tricky, but kind of addresses the same problem of having a lot of negatives everywhere. So like a situation like this, the first thing I would do is just multiply everything by a negative. And make sure to switch the sign. And let's factorize. So x plus 2, x, whoops, that's not the right one. X plus 1, x plus 5. Let's draw our graph. Looks like negative 1 and negative 5 is where our intercepts are going to be. And we want to know, when is this graph greater than 0? It is greater than 0 here and here. Okay, so let's shade this part of the graph. And the solution is x is less than minus 5, x is greater than -1. Good, nice and easy. And let's just pick one last one. Okay, here we go. The next one. Let's just do one more before I wrap up this video. So question 3. We have x squared minus 4x is greater than -5. Okay, now in this one, I'm going to move our -5 to the left-hand side so we gather everything together. Now, when you try to factorize this, you can try, but I believe that it actually will not work out. Like this is not factorizable. And basically, why are we trying to factorize in the first place? Well, I want to eventually see the graph, and I want to see what part of that graph is above 0, right? So if I shift the focus to how do I graph this guy, well, one way we can do it is we can try to do something called completing the square, right? So I can split the 5 into a 4 and a 1, and I can complete the square like this. Now, why is this useful? Well, we can see a quick graph from this one. And we know that from a normal x squared parabola, we're going to go right 2 and then up 1, right? So right 2 and then up 1. And that's basically where our parabola is. And you can see from this graph, if I was to answer, okay, when is this graph above 0? Looks like this is 0 and the graph is always above 0. Okay, so the answer to this question is all real x. Okay, or you can say all solutions. Basically, every x value will satisfy this inequality. Now, again, I will stress that you don't have to graph this to answer the questions, but it does help. But hopefully after you do a lot of these, you can get to a situation like we got down here. And you can realize that the first one is a square that's definitely positive. If you add 1 to it, of course, that's going to be positive. So it's always going to be above 0. Okay, so all of your x values are solutions. Okay, so hopefully that made sense. And yeah, I'll just leave it at that for this video, and I'll catch you guys in the next one.